Assalamu alaikum. My name is Mohammed Zain and my registration number is 20TE11. Today I will tell you about the digital signal processing lab in which we will do lab number 1, and this will be submitted to Dr. Mohammed Jamil. In lab task 1, this is a source code. First, I implement all tasks on laptop, then paste the screenshot so that we explain it easily. In lab task 1, we explain time interval from 0 to minus 0.21 was 0.121 and taken frequency equals to 1. In this, we use the frequency multiplied by root multiplied by 2 pi t, that is sine signal. Now we have to use platform plot command to output of the signal, that is one x is the time axis, other one is the signal that we use to silence this. Now Legend's input signal shown towards sinusoidal signal towards time and sinusoidal. This is the lab task 1. Now move towards the lab task 2. In this we will add the tiles of x and y labels to the existing task. Signal and frequency is same in the previous task as we do in the lab task number 1. We plot signals to comma signal, uh, that same cross one, but add tiles to the next levels like this, y labels to this task also. For applied tiles, we use command tiles, plot of sine wave 1 Hz. This plot of tile input and next level time in C. As we see, x and y is equal to minus 0.05 to 1.5, and axis of y-axis is minus 1.5 to 1.5. Now this is the lab task 2 in which we tell about the commands. Now we will apply commands in which we see x is equal to minus 0.505 to 1.5 and minus 1.5 to 1.5. This was the lab task 2. Now move on the lab task 3 in which we use two signals used to frequency f1 equals to 10 and f2 equals to 520. We use two frequency f1 frequency that is equals to 10, which will use the frequency, and now we have two plot signals. Take signal t along time 2, time will same but x signal is equal to 1 and y signals will be equal to minus 1 to 1, and in this, after doing this, we can see the graph and it can explain us easily. Now moving on lab task 4, it is the same time and same frequency, one at frequency 2, because two signals are taken in signal 1 and use frequency 1 and plot signal in dots. As we see, this output is in dots in blue color and the orange color or red color. Use plot commands in addition with semicolon in dots. As you can see that we use the semicolons. Add green signal to as green signal. This will give again a plot. The signal 2 are recommended and it means that dot will appear but in red color. And this lab task give us tiles that are 0 to 1 are x intervals and minus 1 to 1 are y intervals, that we can see it easily in this. Now moving on lab task 5, we use the source code. Use comments, and comments we use it percentage sign and after percentage what we light over her in it commands. First we use button overhead generate random data from uniform distribute, and again percentage and end mean plot data. As we can see that so n is equal to 50 and again percentage sign. Now we find a uniform line on the output. Now move on the lab task 6. First, we make function and save in this or MATLAB or in our computer. We have created function maximum element, main element and named x. Maximum element equal to maximum as we know, and minimum elements equal to minimum x. In command windows, we use functions. So commands it will give to the version and check what is in this function. First show bigger elements which is 55 and the other one shows the minimum elements that are only 3. This was the lab task 6. Now moving on the lab task 7. In this lab task use function of of my main source. As we can see that minimum is equal to function. First drive function over here, function of main equal to my main of x and set mini value x is equal to 1 as we explain in line number 2. Start loop from first element and store it in the main loop. We use this array x is equal to 3, 5, 3, 7, 5, 2, 9 and call my main function. This was the lab task 8. Now move on lab task 8. Find here maximum element. This was lab is same as lab task 7. First element equal to maximum and check loop and check all elements greater than first element. Now we will do our array and m equals to my function. As we know 9 is the biggest element in this, the value will be displayed to our commandant. This was the lab task 8. Now move on the lab task 9. Lab task 9 is find the average of arrangements. We use function name in its average. As we know the formula of average is sum of all elements divided by number of elements. By doing this we can find the results and these are the sum of x and average are these. Now moving on lab task 7. We are sorting array and name is sort of x and sorted in MATLAB. We use array x is equal to 3, 7, 5 to 9 and call function my sort of x and tested was 2, 3, 5, 7, 9. This was the output. Now moving on lab 11. Function reversed is equal to my reverse. We use function reverse and make it my reverse again. Use reverse and -1 to +1. We call function my reverse and give output 9 to 573 and it is reverse our array. This is lab task 11. Now move on lab task 12. In this lab task two signals are plot. X random signal from 50 to 1 and Y random signals are from 10 to pi 10. As we know that X are random and Y are sinusoidal signals. And these outputs tell us briefly. Now move on lab task 13 and this is the final task. In this we use a source code, a function for and subplots are 2 to 1, 2 to 2, 2 to 3 and 2 to 4 and then finally our output are these. We can explain it easily.